shoot. And let's do a cosmology segment, as it's full of interesting stories today. Today's cosmology segment, starting out with a random object. I picked a quantum random object today before I streamed live. It was number 962, which coincides with this object right here, known as HD 200391, which is a very interesting binary system. It is also known as ER-Vol. So this is a interesting type of star, and I'll talk about that momentarily. Here it is in infrared light. That is the 2 mass you're looking at there. And what's interesting about this is it is a binary system where the binaries actually touch each other. At least their outer plasma spheres touch each other. Here it is on the XMM Newton. And here it is in blue light. And you can see it's a little bit of an oblong looking, you can see sort of 2 lens flare type circles here. And that's because it is a binary system. So this is sort of what's happening in that system. It's not your average everyday eclipsing binary. It is a special kind of binary known as a Ursae Majoris variable. So these aren't your average everyday eclipsing binaries, as every time they get close to each other, they actually exchange material, where plasma gets funneled through their respective Lagrangian point 1, and they interact in some interesting ways. So this is part of the reason why this system is so bright. It's a very close non-eclipsing binary, actually. And you can read about these Ursae Majoris variables on Wikipedia if you like. There's a whole list of them there. And I don't think they even list the one that we're showing here, so it's obviously an incomplete list. But that's something like what's going on with this particular one. And it doesn't show up on the Chandra. But there it is on the XMM Newton, the multi-mirror X-ray project. And again, that is number 962 on the Neil Gorell Swift-Bat X-ray Observatory, ER-Vol. Next, a fantastic imagery here of some Juno mission data showing the morning storms on Jupiter. Now, Jupiter's magnetosphere is created as a result of ionized particles, which come out of Jupiter's volcanic moon Io, and then they get ionized in Jupiter's magnetosphere. And in the morning, we see a situation like this happening at the poles. Juno's been the only mission to really get good imagery of this. The Jovian Aurorae, the morning Aurorae of Jupiter, yes. So some fantastic imagery of that. Jupiter has a very powerful magnetosphere. In fact, Jupiter's magnetosphere is so powerful that if you could see it with the naked eye, it would be about the size of the full moon. So just to give you an idea of how large Jupiter's magnetosphere is, if visible to the naked eye, it would be about the size of the full moon from planet Earth. So this is a phys.org article with some fantastic imagery here from Juno of Jupiter's Aurorae. Also, another interesting story here about the Parker Solar Probe. And our regular viewers would be well aware of these little feedbacks here. You see this little switchback, it's called, where the solar wind just sort of reverses and then returns to its regular flow. Well, there are 2 new theories about this. And I don't know, you may think they're new, you may think they're not new. I'm not sure how excited you'll be about the story, but in any case, they are talking about magnetic switchbacks. Are they caused by a magnetic flux rope, or are they caused by magnetic reconnection, or perhaps they're just caused by interaction between the slow and fast solar winds? The real answer is we don't know, but there's a SciTech Daily article about it. You'll probably find it all over the Science Wire. Some folks attempting to explain the switchbacks, the zigzagging of the solar wind, as detected by the Parker Solar Probe, which, by the way, is also the fastest object ever created by mankind that we know of, and the closest object that we've ever sent to a star. So the Parker Solar Probe is interesting in that it has gone faster and closer to the local yellow dwarf than any other object ever has. And there is one of the diagrams of the possibilities of what causes, what's the physics behind the switchbacks. I'll just let the rest of the article scroll here so that you can view it without even clicking on SciTech Daily. You can just watch our video. And here's a great animation also of the Parker Solar Probe passing through one of those switchbacks, where the solar wind is going in different directions over a brief period of time. Do you have a theory as to what causes this? Well, leave us a comment and let us know, as we consider our YouTube channel to be a collaborative effort. And that's today's Cosmology segment. I think it was pretty vast. I think it was pretty full of information. So make sure you press like and subscribe if you're viewing on YouTube. Leave us a comment if you view on BitChute. And don't forget to share the videos with your friends, your foes, your science noobs, and your science pros. Let's move on.